Hello, this is John from caveofprogramming.com. In this tutorial we're going to take a look at arithmetic in C++. So we've seen a lot but not all of this before, and we're going to take a bit of a closer look here before we get on later to looking at pointer arithmetic. So plus, minus and multiplication don't really need any more explanation, I don't really think, than we've already gone through. But there's a bit of a gotcha with division, which is that, let's say you do int value 1 equals 6 divided by 2, and then do cout value 1. This does what you'd expect. So if we run this, then we should get 3. But look what happens if we do 7 divided by 2, we still get 3. Even if we change this to double value 1 equals 7 divided by 2, and we run this, we're still going to get 3. And the reason for that is whenever you divide an integer by an integer in C++, it will always discard the remainder. It won't do floating point division, it will do integer division and just throw away the remainder. If you want this to be floating point division, one of these has to be a floating point number. So like if we had 7.0 divided by 2, that would work. And sometimes you can't do that, for example, because this could be a variable, or they could both be variables. But like an easier way to tackle this is just to cast one of them to a double or a float. So we can type double in round brackets before 7, and we call that casting 7 in this case to a double, and then we get true floating point division and we get 3.5. Casting is something that's often useful. We can use it to convert certain kinds of types into certain kinds of similar types. You can also cast a double to an int. So let's say we have int value 2 equals 7.3. We can actually do that, but the compiler will issue a warning. It's possible some compiler might even throw an error. My compiler just gives a warning with this. I'm using GNU here. So we got a warning there, which seems to have now vanished for some reason, but it did actually run, and we get 7. So it's just thrown away the remainder because we had a double here and we're trying to put it into an int. But to get rid of the compiler warning, we can cast this explicitly to an int, and then we will still throw away the remainder. I will throw away the stuff after the decimal point, and we'll get an integer. So this gives us 7, and there's no compiler warning when it compiles. So we've got this here. Yeah, that's just saying that's from something earlier by the looks of it. That's a different project. Okay, so there's no warning here. So this won't do rounding. It won't round up or down. All it does is throw away the stuff after the decimal point. If you want to do rounding, you'll have to use a special maths function to do that. We've also got a bunch of operators like this: plus equals, minus equals, divide equals, times equals, and also mod equals, and we'll look at mod shortly. But let's take the simplest version of this. Let's say we've got int value 3 equals, let's say 8. If we do value 3 plus equals 1, that's the same as doing value 3 equals value 3 plus 1. Or it's the same as value 3 plus plus. All of these three things are equivalent. So if we do cout now, value 3, what we get is it's going to be 9. So let's run this, and it says 9. So the value in this lies in that the reason this, normally if we wanted to actually do this, would do this because it's the shortest syntax, value 3 plus plus, but we can add other stuff on here, and we can also use this with different arithmetic operators. So let's take another example. Int value 4 equals 8, again let's say, or maybe 10, and value 4 divide equals 5. that's the same as doing value 4 equals value 4 divide by 5. So these divide equals, multiply equals, plus equals, negative equals, they're the same as these expressions, these kinds of expressions. They just avoid you having to repeat the variable. So we're just assigning, we're doing the division, value 4 divided by 5, and then assigning it to value 4. So that is often quite handy, just because it's a bit quicker to type, really. So let's just run this, and we'll see that it's going to be equal to 2. The mod operator is another thing that I want to show you, and again, this is very, very useful for various reasons, some of which we'll probably see later on in this tutorial series. What mod does is it does integer division and then gives you just the remainder. So let's say we have int value 5 equals 12 mod 5. So this is called modulus, modulo, or just mod for short. Then what we get there is 2. So let's do value 5 here. So it's 12 divided by 5, and then just take the remainder and store it in value 5. That's what mod does, this percent sign. So here we get 2. Of course, if it was 13, it would be 3, and so on. Let's just have a look. So we've got 3 there. Operators, they have always a precedence. Excuse me. So if you can write out complicated expressions like, let's say double. I don't know. I'll just call it equation equals 5.3. 5.3 divided by 4 plus 2 times 6. And we can do C out on that equation. And C++ will figure out the meaning of this because certain operators have higher precedence than others. So in this case, division and multiplication have a higher precedence than plus, which means that they will be done first. So that's the same as if we put round brackets around these bits. That makes it clear that first we're doing these and then we're doing the plus. So we expect the same result now, 13.3, if I've got my operator precedence correct here. There we go. It's it's basically the same, more or less. But it's bad to write expressions that don't have brackets around them and to rely on operator precedence, because it's just not easy to remember always which order the operators will be applied in. And in general, most of the time, it's much better if you have a complicated expression like this to put round brackets around relevant bits, so that this could be even more complex. We might want to do, I don't know, mod 2, and we might want to do all of this stuff first. So here we're saying divide 5.3 by 4, then do mod 2 on it, so get the remainder after we divide by 2, and then add to that and do 2 times 6, and then add 2 times 6 to it. So but it's a lot clearer. Oh, we've got a problem there because we're applying mod to a floating point. Let's do something like 5, and I'll change this to a double just so that we have a double result. Let's try building that, see if that works. Build project and run. So it's always much better to put brackets in, even if they have to be nested. Nested brackets are not very readable, but they're a lot more readable than if we had the same expression without the brackets. So with the brackets, we can see, okay, first we've got to do that, then we've got to do that, and we've also got to do this, and then we can add those two things together. But if we had that without the brackets, it would look like this, which, for me is is getting to be really quite unreadable because I'm not really sure which has precedence, division or mod. I know that multiplication and division have precedence over plus, but it's getting ridiculous now. So don't do this. Always put round brackets in to make your expressions more readable. So I think that's everything that I want to cover in this tutorial. I'm going to give you a couple of exercises to help get this into your mind. One is take a large number of seconds, like more than several hours, and convert it to hours, minutes and seconds. So you can do that in various ways using a combination of arithmetical operators used judiciously. Try to do it in the most efficient way you can, but if you can get the right result at the end of the day, then you've succeeded. And you can always check it by multiplying seconds by 60, adding it to minutes times multiply minutes by 60, add it to the number of seconds, and multiply hours by 3,600 and add them all together to get the number of seconds back again, and check that you get the number of seconds that you originally had when you convert it back into seconds, if you see what I mean. So that's a good little exercise. And another exercise is write a for loop that iterates, let's say 10,000 times. Output a dot on the same line, so a bunch of dots one after the other on the same line every 100 iterations. So for example, you might want to process a bunch of XML records. You might have, let's say, 100,000 XML records, and you want to process them with a program that you'll run on the command line, and you want to show progress, but you don't want to output a dot for every single record, because you'll have a massive console full of huge numbers of dots. It's better to output a dot every time you processed 100 records, and then the dots appear at a more manageable rate. And to do that, you can use the mod operator. So to do this, to output something only every certain number of loop iterations, you can do that using the %, the mod operator. So have a go at that and see if you can get it to work. I'll leave you with those two exercises for this time. So until next time, happy coding.